This is Unit 5, Right Triangles. Preview video 5.3, SOH CAH TOA. Students, of all the videos you're going to watch this year, this one is by far the most important. Pay attention. Don't multitask. Ready? Let's breathe. Close your eyes and inhale. Deep breath, hold. And birthday candle. Good job. Alrighty, before we go anywhere else today, you need to get your scientific calculator and you need to make sure it's what's called the correct mode. It's called degree mode. So you're going to have one of three style of calculators, and the way you're going to check if you're in the right mode is we're going to do something called the sine of 30. Now, you have absolutely no idea what the word sine means, or 30 for that matter. It means 30 degrees. So the sine of 30 degrees. And you're like, I don't even know what sine is. It doesn't matter. All you need to do is check your calculator. So, some of you, your calculators, you do sine 30, close the parentheses, equals. And if you're in the correct mode, you should be getting 0.5. Some of you, your calculators, you go the other way. You go 30 sine. Same thing. Notice it's 0.5. Now, if you have a large screen calculator, it's important you get it in what's called degree mode before you start. And let me show you how to get in degree mode. This is only the large screen calculators. The small screens are automatically degree mode. The large screen, everything you will get will be wrong unless you do this first. Watch. Hit the on button. Mode. Arrows, down, down, over. The word degree is flashing. Enter. Clear. I'll do it again. Mode. Down, down, over. Degrees are flashing. Enter. Clear. This is how you know you've done it correctly. Once again, sine 30, close the parentheses, enter. Ta-da! 0.5. What does that mean? You'll find out in approximately 11 minutes. Now that you're in the correct mode, let's go to our lesson, 5.3. Don't forget date, time, and location. So if you have a small screen calculator, it's automatically in degree mode. Large screen calculator, again, it's mode. Then you go down, down, over, degrees flashing, enter, clear. We're going to do a little experiment. Everything we're doing is based on the Pythagorean Theorem. So from the Pythagorean Theorem, we got 30, 60, 90 triangles. Remember? 30, 60, 90, short leg, root 3, short leg times 2. So in this 30, 60, 90, short leg is 6. The long leg would be 6 root 3. Keep my color straight. I think I was using green last time. Okay, 6 root 3, and then to the hypo it's times by 2. And we get 12. So in this 30, 60, 90 triangle. So I want you to convert 6 root 3 to a decimal. And the way you're going to do that is, I'm going to only use the large screen calculator here. Okay, first we're going to get we're trying to get 6 root 3 into a decimal because I want you to see 6 root 3 as a decimal. So on this calculator on the left, first we're going to do the square root of 3. So second function, the square root button's right there. So we get square root of 3, enter. And we get that on this one. The square root button's right there. So second function square root 3. Okay, that's square root 3 times by 6 times by 6. We get the same number, 6 root 3. That's 6 root 3 as a decimal. Ready? Let's take a look here. We want to round it to the 4th decimal place. So it's going to be 10.3923. Just keep that in mind. 6 root 3 as 10.3923. You're going to need to get over your aversions to decimals, folks. Okay? Now, do a little experiment here. We're going to make some fractions because you just love fractions. From that 30, this is the 6 divided by 12 is 0.5. Okay. 6 root 3 divided by 12, you can do this on a calculator. Remember, 6 root 3 is 10.3923. So on your calculators, we're doing 10.3923, and we're dividing by 12. That decimal, we take it to the 4th decimal place, 0.8660. And then we're going to do 6 divided by 6 root 3. And again, 6 root 3 is 10.3923. So 6 divided by 10.3923. We get that decimal, take it to the 4th place, 0.5774. And you're like, what's going on, Ms. Way? Just relax. There's a reason for everything. I just want you to see something. Like, where are all these decimals coming from? So all we've done is we've made fractions of sides of right triangles. Fractions. Now, code for fractions is the word ratio. We're dealing with different combos of ratios of right triangles, sides, and we're getting these wacky decimals. What's up with that? You'll see in about 8 minutes. So now I want you to see here, remember we did that? Those wacky ratios have names. They're called sine, cosine, tangent. Look, look, look. Ready? I'm going to take a cut and paste. And we're going to come over here. I just want you to see this right next to each other. You still won't understand what this means. I just want you to see it. That's all. Watch carefully. Now, in your calculators, I'd like you to do the sine of 30, cosine of 30, and tangent of 30. And we're going to write down those decimals. You're like, Miss Way, I don't even know what sine, cosine, or tangent stand for. Totally get it. That's fine. I just want you to notice. Okay, so in our calculators, clear, clear. And I'm going to get all 3 calculators because yours is going to be one of all 3. Okay, so sine of 30. Sine 30, enter. Notice it's 0.5. Big calculator. Sine 30, enter. Notice it's also 0.5. Some of your calculators are backwards. So you're going to go 30, sine. Notice it's 0.5. What's up with that? So in this case, the sine of 30 is 0.5. Let's do cosine. Cosine of 30. Let's see what's up with that. This calculator, cosine 30. Notice the decimal. This calculator, cosine 30. Notice the decimal. This calculator goes backwards, 30 cosine 0.8660. Wait a minute, we've seen that before. We've seen that before. Let's do something called tangent, which the abbreviation is TAN. Tangent of 30. Ready? Tan 30. Look at that decimal. Looks familiar. Tan 30. Same decimal. Look at this one. 30 tan. It's the exact same decimals. So there are ratios stored in your calculator. And these ratios have a magical name called sine, cosine, and tangent. And I'll explain that about 1 minute, 30 seconds. And all of those ratios are stored. When I say ratio, think fraction. Ratio, fraction, fraction, ratio. Interchangeable. All those ratios are stored in your calculator. We'll talk about that, why and how in a moment. So far you have 3 tools in a right triangle. Let's review them. Have 2 sides, need a 3rd side, Pythag. So that's leg squared plus leg squared equals hypo squared. You use that when you have 2 sides and you need a 3rd side. Then we had 45, 45, 90, leg, root 2. In a 45, 45, 90, the legs are equal, and the hypo is whatever the leg is times root 2. Then you had 30, 60, 90, short leg, root 3, short leg times 2, 30, 60, 90. Whatever your short leg is, to the long legs times root 3, towards the hypo, times by 2. Simple enough. Okay, so what if you have a triangle that is not 45, 45, 90 or 30, 60, 90, and you don't have 2 sides? What if you only have 1 side and an angle that's not 45, 45 or 30, 60? Well, what if your angle is 41 degrees? Now what? So this is our most powerful tool you will learn in geometry, by far the most powerful tool. We're doing something called trigonometric ratios. That word ratio, just think fraction, it's no big deal. And those 3 ratios, which are fractions, are called sine, cosine, and tangent. Now to work with these ratios, I need to introduce some vocabulary to you. The vocabulary of hypotenuse you're already familiar with, but then I need to define what the words opposite and adjacent. The symbol of theta is commonly used in mathematics as well as physics. We use theta, which looks like a circle with a line in the middle, to represent an unknown angle. So theta is used for an unknown angle, just like x is used for an unknown number. So coming here, what defines opposite, adjacent versus hypo? So take a look here. When the theta moves, the opposite adjacent move. So I'd like you to physically sweep the theta. That's the angle we're working with when I say unknown angle. The opposite side is across from the theta. So here, this side would be considered the opposite. Touching the theta would be the adjacent. Adjacent means next to. Hypo never changes. Hypo is always the right angle points to the hypo. Hypo never changes. Opposite and adjacent can. Opposite and adjacent can change. Let's do another one. If this is your theta, across from the theta that's your opposite. The side touching the theta, that's your adjacent. Adjacent means next to. The hypo is always opposite of the right angle. It's important that you can label opposite, adjacent, and hypo. Taking a look down here. Ready? Now we have a given angle, and our given angle, our theta is 32 degrees. Where is the opposite and adjacent in relation? Opposite means across, so this x would be considered the opposite. 15 would be considered the adjacent. And y in this case is the hypo, because the hypo is always the right angle pointing. I want you to take literally like 30 seconds. Label the opposite, adjacent, and hypo in both triangles. 30 seconds, go. If you know what you're doing, you should really be able to do it just about that fast. Let's check your work. By the way, I'm color coding. I'm using red for opposite, green for adjacent, and blue for hypo, just FYI. So right here, if your theta is the 54, your opposite is the y, your adjacent is the x, and your hypo is the 24. If your theta is 21, that means your opposite is that 8. Your adjacent is the x, and your hypo is the y. It's super important. You could label opposite, adjacent, and hypo. Now, what is a trigonometric ratio? It is the ratio. When you see the word ratio, you should automatically think fraction. Fraction, ratio. It is the ratio of two sides of a right triangle in reference to a certain angle. And we'll call that angle theta. And these three ratios have very particular names. The first ratio is opposite over hypo. So here, if we're working with angle A, our opposite would be 3, our adjacent would be 4, and our hypo would be 5. So one of the combos we could do would be opposite over hypo. Notice it's O and H. There's a reason why I'm putting an OH there. And in this case, our opposite is 3, and our hypo is 5. If you take $1 and divide by 5, it's 20 cents. So then you count 3 of them, 20, 40, 60. So one of the ratios is opposite over hypo, and in this case, it would be 0.6. Same triangle. Adjacent over hypo would be 4. Whoop, let me keep my color straight here. That's adjacent is green. Over 5. If I take $1 and divide by 5, that's 20 cents. And then I want 4 of them, so 20, 40, 60, 80. And I get, so adjacent over hypo is another combo. There's 3 of them total. Still not making sense. Totally okay. Don't worry about it. I promise in about 12 more minutes, all of this is going to go bing and be so amazing. Our last combo is opposite over adjacent. And in this case, Our opposite is 3. Our adjacent is 4. And 3/4 of a dollar, 0.75. These 3 combos of ratios, opposite over hypo, adjacent over hypo, opposite over adjacent, have 3 very particular names. Opposite over hypo is called the sine ratio. Adjacent over hypo is called the cosine ratio. Opposite over adjacent is called the tangent ratio. It's in that and only that order. And to help you remember this, we have an acronym. This acronym is called SOH CAH TOA. And the way you're going to remember it, it looks like this. The sine ratio, sine of theta equals opposite over hypo. Cosine theta equals adjacent over hypo. Tangent theta equals opposite over adjacent. And you're going to remember it like this. You can come up with your own way to remember. SOH CAH TOA. So think of it like this. So, like you're trying to win an argument. You're making your final point. Let's do it with me. Fingers up and like you're trying to win an argument. So, ready? Put your thumbs underneath your armpits. Yes, you're actually doing this at home. You're going to scare your siblings, maybe your dog, maybe your parents. That's totally okay. Put your thumbs underneath your armpits. You're now a crow. Go, caw, caw. Okay, ready? Last one. Stomp your foot. Someone just stomped on your foot. You're in pain. You're in pain. Oh, my toe. My toe. Say toe. Okay, ready? Totally do this with me. Freak your parents out. Totally fine. You can explain later. So, stomp your foot. You're in pain. Toe. So, TOA. You're like, why am I doing all these antics? Because I don't want you to forget. Ready? We're going to find the sine ratios. Relax, your teacher has not totally lost her mind. Not completely anyways. Ready? We're going to work with Z. So sweep Z. From Z, label. This is your opposite. This is your adjacent. This is your hypo. We're going to find the cosine ratio. Remember, ratio means fraction of Z, cosine. And what is cosine? Cosine is ka. So the adjacent here would be 20. And our hypo would be 29. Yes, at this point, you can go grab those calculators. That's going to be 20 divided by 29. You're going to take, when you're doing with these ratios, always take it to the 4th decimal. 0.689, and that's going to round up to 7, 6897. That is the cosine ratio of angle Z. Cosine ratio. Ratio, code for fraction, code for decimal. Ready? You got 20 seconds to find the tangent ratio of angle A, tangent. Okay, so angle A is here, which would make 8 your opposite, 15 your adjacent, and 17 your hypo. Tangent is toa, ooh, like ow, I'm in pain, ooh. So O is 8, adjacent is 15. So you simply, the tangent of angle A is 8 divided by 15, take it to the fourth decimal, 5.333, blah, blah, blah. Repeating. Now, what's up with all these ratios? What's important for you to know is that these ratios, now remember we started with this, sine of 30, cosine of 30, tangent 30. There's actually hundreds of them that have ratios related to specific angles. Like, for example, here's this giant chart, and you also have this chart in your reference booklet. The sine of 30 is 0.5. The cosine of 30 is 0.866. The tangent of 30 is 0.577. Guess what? That giant chart is stored in your calculator. That's what all these amazing decimals are. These ratios, certain combos of right triangle sides in reference to specific angles, sine, cosine, and tangent ratios, fractions, are all stored in your calculator. How do you use them? We're going to do that together. Ready? Oh, this stuff's magic. This stuff's magic, and it's not hard. I promise. Don't freak out on me. It's not hard. Okay, you ready? You're looking at this page. We're going to do 3 problems together. All right, step number 1. You label opposite, adjacent, and hypo. So from this angle 24, the x is our opposite. This side here is the adjacent. Across from the right angle is the hypo. This chart is in your reference booklet as well. That's on that right triangle toolbox. All right? So, what do we have in this case? When you say have, where do you have a number, a value? We have our hypo, which is 16. So we're going to write hypo. What do we need? Our x. Our x is sitting at the opposite. Now, it doesn't matter whether this says HO or OH. Whatever combo that is, what goes with some variation of OH, we go right here to this chart, and it is so, and you write exactly this down. Exactly. Exactly this. Watch. The sine of our angle theta, SIN is abbreviation for sine, over 1 equals the opposite side over the hypo. This never changes. You don't flip this, regardless of what's up here. Okay, ready? We're going to solve for x here. And we're going to solve for x using these stored ratios, sine, cosine, tangent ratios that have been stored in your calculator. Let me show you how to do that. It's not hard, I promise. Step number 1, you've determined its sine. You write that down. Sine of theta over 1 equals opposite over hypo. Now you're going to circle, plug, chug. Sine of theta. Sine of 24. Put parentheses around this entire entity. This is super important you understand this. This is not 24. It's the sine of 24. And I'll explain how to find that in just a second. Over 1 equals circle opposite. What is your opposite is x. Circle hypo. Our hypo is 16. Super important. Never, ever, 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 ever touch a calculator. Don't touch the calculator until x is isolated by itself. Let me show you what I mean. Right now, x is not by itself. Don't touch your calculator. Always get x by itself. Then you can grab your calculators. Ready? Let me show you what I mean. Boom, boom. We're going to cross multiply because it's a fraction and a fraction. So I get x equals sine 24, keep parentheses around that, times 16. Is x by itself? Is x all by itself? The answer is yes. Great. I'm going to show you how to get this answer on two different calculators. Okay, sine 24 times 16. Watch. I'll do the big string calculator since most of you have that. Okay, watch. You do sine 24, enter. That's that ratio, that sine ratio of that particular angle. There's your decimal. Now we're going to times it by 16. Take your final answers to the second decimal. And look what we got here, folks, 6.51. Now, some of your calculators are going to go the other way. So let me show you what I mean. Watch. Sine 24 is going to be 24 sine. There's that decimal. Times 16. And there's your answer. Make sure you're getting the same answer as me right now. Make sure you know how to use your calculator. This calculator is the same as the big one. Sine 24, enter. You get that decimal, times 16, enter, getting the same thing. 6.51. Now you can solve for any side length with any angle in a right triangle. This is so powerful. Let's do another one. Example 2. We're doing it together. Relax. Okay. Step number 1 is to label your opposite, adjacent, and hypo. So if I'm working with 58, this is the opposite side, this is the adjacent side, and of course the hypo is always across from the right angle, so the hypo never changes. Have, need, do. We have the hypo. We need, in this case, the adjacent. So it doesn't matter whether it's an HA or AH combo. You should have this right in front of you. This is the right triangle toolbox. We're going to flip it over. And you're looking at the left-hand side right here, left-hand side where it says working with the side. This is what you're looking at right here. Okay? So here we have an AH combo. You go here on the chart. What goes with AH? Ka! Ka! And you copy exactly this down. Cosine of theta over 1 equals adjacent over hypo. Now, you circle, plug, chug. Your theta is 58. Put parentheses around that. Your adjacent is x. And your hypo, circle, plug, chug, is 11. Don't touch that calculator until your x is by itself. So x is by itself. The cosine of 58 times 11 is going to give us that value of x. Again, two ways to do this on your calculators. So we're going to do cosine 58 times 11. Big calculator. Cosine 58, enter, times 11, enter. I'm getting 5.83. This one goes the other way around. Watch. 58 cosine times 11. Notice the same thing, 5.83. So our value of x is 5.83. And then whatever units we're dealing with, inches, meters, whatever it is. Let's do another one. Sweep the angle you're working with. So right now the 20 is the opposite, x is the adjacent. Here's your hypo. Have, need, do. We have the opposite side. This time we want the adjacent. Now, it doesn't matter whether this reads OA or AO. You ask yourself, what is the combo that goes with O and A or A and O? It doesn't matter. You take a look again at this green chart right here. What goes with OA is TOA. OA. Someone stepped on your toe. TOA. Copy exactly this down. Woo, 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 woo. Miss Way, skipped a step. Ah, bad girl. Bad girl, bad girl, bad girl. That is Miss Way's example of what not to do. You do not immediately plug the numbers in. No, no, no. No, no, no. You are not supposed to do that. You write down the equation. Tangent of theta over 1 equals opposite over adjacent. That's the original tangent equation. Now, circle plug chuck. Theta, theta. Keep parentheses around that. Our opposite is 20. Our adjacent is x. Do not touch a calculator until your variable is by itself. Cross multiply. This reads tangent of 47 times x equals 20. Careful, don't touch your calculators yet. X is not by itself. We have to divide out the tan 47. That's a single entity. So if we get x by itself, it's x equals 20 divided by the tan of 47. Notice it's a little different. X is by itself. Watch on a calculator. If you have this kind of calculator, you can follow with me now. So I first do 20 divided by tan of 47. So I go tangent 47, parentheses, enter. There it is. X equals 18.65. On this calculator, it's going to work pretty much the same way. 20 divided by the tan of 47. Enter. You're getting the exact same thing. Some of your calculators, again, are going to work backwards. Watch. You do 20 in this calculator divided by 47 tan. enter. Get the same thing. So we have done example 1. There it is on your calculator. Example 2 on your calculator. Example 3 on your calculator. I'd like you to summarize what you've learned today in those 3 main bullet points. Take a photo of all the pages, 28 through 30, 21 through 38. Load it to ClassKick. 1 slide per page.